Hello and welcome back. In the previous session, we had seen the definition of some of the basic terminologies such as symbols, string length, languages, etc. Along with that, we had also seen what do we mean by automata theory and also the definition of finite state machine. In case you are not aware about such terminologies that we will be using henceforth in all of our sessions, please do visit my previous video and then continue with the current video. In this session, we will be designing two types of finite state machines which will be validating decimal number whether it is divisible by 3 or whether it is divisible by 4. So let's begin. Let's revise the definition of finite state machine. Finite state machine consists of finite set of states S which alter on receiving the input set I to produce the output set O. And it defines two functions called as state function STF, which is defined by S cross I, which will give us the next state. Along with that machine function, that is MAF, defined as S cross I, giving us the output O. Let's have a look at the question. The question says, design FSM to check whether the given decimal number is divisible by 3 or not. So here, the question is clearly stating that we have to check whether the given input decimal number is divisible by 3 or not. We will be coming across with such type of number systems such as binary number system, ternary number system, etc. But here we are beginning with the decimal number system, which is very simple to design. So let's begin the solution. Our solution will be consisting of 4 steps, out of which step number 1 is theory, that is definition. So the definition says FSM consists of finite set of states S which alter on receiving the input set I to produce the output set O. Step number 2 is logic. In logic, we will be defining our 3 sets, that is S, I and O. Now here, since I is equal to decimal number, we will be having the set of 0 to 9 number set. The O is going to consist of Y and N, representing yes and no as our output. And finally, S will have QS, Q0 and Q1, Q2 states. Each QS representing our start state or initial state. That means just like our machine has a power button which on clicking will start our machine. Similarly, the QS will be our power button for our FSM, which will begin or push our machine into start state. Then Q0, Q1 and Q2 states represent the remainders. When any given decimal number is divided by 3, we can get only 0, 1 or 2 as the lowest minimum remainder. So using that logic, we will design this FSM with states QS, Q0, Q1 and Q2 respectively. Here the formula base into R plus input mod number will be useful in our next session. Just for your reference, keep it noted down on your book. In this division, we will be seeing how our machine is going to work by taking a simple division of 6 to 4 number by 3. When we try to divide 6 to 4 by 3 in our school time, we have learned that we first take the first digit of our number, check whether it is divisible by 3 and then move on to the next digit by carrying it forward for our next division step. Here we are not concerned about what we will be getting in the quotient. Rather, we are just simply interested in the remainder of our division because we can conclude whether a given number is divisible by 3 or not unless and until we get the remainder as 0. We divide 6 by 3, get the remainder as 0 and carry forward 2. Now this 2 is not divisible by 3, so we keep the quotient as 0 and carry forward 2 along with 4, which is our next digit of the number 624. So when we divide 24 by 3, we get 0 as the remainder. thus concluding that 624 was divisible by 3 completely, and it will give the output as yes, it is divisible by 3. Let us continue with a solution of the question. Design FSM to validate whether the given decimal number is divisible by 3 or not. We had reached till step number 2, that was logic. In this step, we will be designing the implementation of our machine. So here we have to define STF and MAF tables respectively. In STF, as we can see that there is S and I as mentioned in the definition, that is S cross I will give us the next state. So your S is nothing but states, which is QS to Q2, and I is nothing but set of numbers which when divided by 3 will give us remainders as 0, 1 and 2 respectively. That is, the first set consisting of 0, 3, 6, 9 when divided by 3 will always give us remainder 0. 1, 4, 7 will always give us remainder as 1 when it is divided by 3, and last and final set consisting of 2, 5, 8 when divided by 3 will give us remainder as 2. The state QS has an arrow in front of it trying to represent that it is our start state or initial state. Q0 has a star marked over it, which is representing that it is the final state which will give us our final output. Q1 and Q2 states are representing remainders when divided by 3 as 1 and 2 respectively, along with Q0 representing remainder as 0. Now let's begin the actual solution. If we have the number as 312, what will happen? In the initial state, when we are in QS state, if the first digit I am getting is 3, I divide this 3 by 3, I will get remainder as 0. So from QS, when I get either 0, 3, 6 or 9, I will get remainder 0. So I have to transit to Q0 state. Next, if I get in the beginning the first digit is 1, then I have to transit to Q1 state, because when I divide 1 with 3, I am going to get the remainder as 1. Suppose my number is beginning with 2. Then when I divide 2 with 3, I am going to get remainder as 2. So I have to transit to Q2 state. Similarly, when I reach Q0 state, that means my previous division's remainder had given me 0. Now, when in the next state or the next digit which I get in the number is suppose either 0, 3, 6 or 9, I will be able to divide that number completely with 3 and I will get the remainder as 0. So I have to stay in the same state. Now, since I am in Q0 state, my previous division had given me remainder 0. Next input if I get is a 4 or 1 or 7, it will become 1, 4 and 7. When I divide this number with 3, I know that I will get the remainder as 1. So I have to transit to Q1 state. Next, when I had done the previous division, I had got the remainder as 0 and I carry forwarded the next digit as either 2, 5 or 8. I am going to get the remainder as 2. So I have to transit to Q2 state. Next, in Q1 state, when I have reached the Q1 state, my previous division had given me remainder as 1. So if the next digit I am getting is either 0 or 3 or 6 or 9, then when I divide this number, that is 10, with 3, I know that I will get the remainder as 1. So I will have to stay in the same state, that is Q1 state. If my previous division's remainder was 1 and I get the next digit as 1 or 4 or 7, it becomes 11, 14 or 17. When I divide this number with 3, I know that I am going to get the remainder as 2. So I will transit to Q2 state. Suppose my previous division's remainder was 1 and next digit if I get is either 2, 5 or 8, it will become 12, 15 or 18 respectively. When divided by 3 is going to give me remainder as 0. So I have to transit to Q0 state. because that is the state representing remainder 0. Once I have reached Q2 state, that means my previous division's remainder had given me 2. Now, next digit if I am getting is a 0 or 3 or 6 or 9, I know that I am going to get the remainder as 2. So, I have to transit to Q2 state, that is stay in the same state. Now, in the next, if suppose my next digit is either 1 or 4 or 7, I know that I am going to get the remainder as 0. So, I will go to Q0 state. And finally, if my next digit appearing is 2, it will become either 22, 25 or 28. Thus, giving us the remainder as 1. So, I will transit to Q1 state. So here our table will look somewhat like this, that is Q0, Q1, Q2, Q0, Q1, Q2, Q1, Q2, Q0 and Q2, Q0, Q1. Now our MAF table will have the same type of setting except that instead of state transitions there will be output displayed in this table. So wherever Q0 is appearing in our transition table, that is in the right hand side part of our table, there it will be y, and rest all the states, that is Q1 and Q2, will have n as our output. So wherever there is Q0 state appearing in our transition table, there we will be giving the output as y, because that is what is proving that the given number is divisible by 3, and rest, that is Q1 and Q2, will represent n, that is the number is not divisible by 3, hence it will output n. Continuing with our solution, in step 3 there is third part, that is state transition diagram. In this state transition diagram, using the STF and MAF table, we will draw a directed graph for our transitions. So from QS, we know that we have to go to either Q0, Q1, Q2 depending on what input is given as first digit of our number, and continue our transitions from Q0, Q1 and Q2 state. Do remember that from each state, each output, there will be, here there were 3 sets of output. So we will have 3 transitions appearing from each state. The step 4 of our solution is to solve an example. Now here we have taken an example, that is QS, 7283. We have to give this as the input to our machine and check whether the given input is divisible by 3 or not. Here we have written QS, that is our start state. That means our QS will take 7 as our first input and push the machine into running state. So here this slanting T is representing transition. So here Q1 in QS, after getting 7 as our first digit, it will transit to Q1 state. From Q1 on getting 2 as the input, it will transit to Q0 state. Q0 on getting 8 as the input, it will transit to Q2 state, and finally on getting Q2 as 3 as the input in Q2 state, it will stay in Q2 state and give the output as no. So as you can observe from the state transition diagram, we can simply or easily trace whether the given flow of the transitions are correct or not. In case you are not able to read the transition diagram, you can refer to the STF, that is state transition function table, to check the flow of the input. Let us check another example. QS, 312. So from QS, on getting 3 as the input, we will transit to Q0 state. From Q0 state, on getting 1 as the input, we will transit to Q1 state. And from Q1 state, on getting 2 as the input, we will transit to Q0 state and put the output as Y. That is, yes, the given number 312 was divisible by 3. I hope the previous example was somewhat clear to you all. In case you haven't got a hang of it, let us solve another example. that says design FSM to check whether the given decimal number is divisible by 4 or not. Here only the divisor has changed. So let's begin the solution. Step number 1 is theory, that is definition. Step number 2 is logic, where we will be defining S, I and O respectively. Again, here since the input says decimal number, our I is going to consist of 0 to 9 numbers, that is decimal number set. O will again remain y, n, that is yes and no. And finally, the states will become Qs to Q3. Now here Q0, Q1, Q2, Q3 represent the numbers that we can get as remainder when any decimal number is divided by 4. So we can get either 0, 1, 2 or 3 as the remainders when any decimal number is divided by 4. Again, here the reference, in case you have forgotten to note down the formula, you can still write it down in your book. Again, here is the explanation, small explanation of how our number divisions take place. So here we will just quickly go through it and conclude the solution with step number 3, that is implementation. So here we are going to follow the same steps or the same format that we did when we had to check whether the given decimal number is divisible by 3. We have to take care that we carry forward the remaining digits of our number. So let's continue with the solution with step number 3, that is implementation. In implementation, we are going to design STF and MAF just like our previous solution. So in STF, we have S cross I, where S are the states, that is QS to Q3, and I are the numerical decimal numbers ranging from 0 to 9. Again, as you can observe, we have created set of numbers from 0 to 9, which will give us the remainders as 0, 1, 2 and 3 respectively. So first set, as you can see, has 048, which when divided by 4 will give us remainder 0. 159 when divided by 4 will always give us remainder 1. 26 will give us remainder 2 and 37 will give us remainder as 3. So let's begin. When we are in QS state, that is our start state, if I get 048 as our first digit beginning of our number, we will get remainder as Q0. That means 0. Then when in QS, if I get the first digit as either 159, I know that I will be getting the remainder as 1, so I have to transit to Q1 state. 2 or 6 when appear as the first digit of our number, we will get remainder as 2 and transit to Q2 state. And finally, 3 or 7 when appear as the first digit of the number, when divided by 4 will give us remainder as 3. So we have to transit to Q3 state. The similar pattern will be followed for Q0 state because the previous division had given us a remainder as 0. So it will be like we will be dealing with the same numbers which are appearing in the sets as it is. When we reach Q1 state, the previous division remainder was 1. So when we have 1 and the next digit appearing is either 0, 4 or 8, we will get remainder 2. So we will transit to Q2 state. When the previous division's remainder was 1 and next digit input I am getting is either 1, 5 or 9, I know that I will get the remainder as 3. So I transit to Q3 state. Similarly, when 12 divided by 4 or 16 divided by 4 is going to give me 0 as the remainder, so I transit to Q0 state. And finally, 13 when divided by 4 or 17 when divided by 4 will give me remainder 1. So I transit to Q1 state. For Q2, it is like the previous division's remainder is 2. So we will get either Q0 state, 1, 2 and 3 respectively. Okay, so here 20, 21, 22, 23 when divided by 4 is going to give me remainders as either 0, 1, 2 or 3 respectively. Finally, when we reach Q3 state, that means the previous division remainder was 3 and next digits when appear is either going to give me remainders as 2, 3, 0 or 1. So we transit to Q2, Q3, Q0 and Q1 states respectively. Again for this in MAF table, wherever Q0 is appearing in STF table, we will write Y and rest Q1 to Q3 we will be mentioning as N, that is no, the number is not divisible by 4. I hope this is somewhat much better to understand since we have already solved one example based on the similar concept. Continuing with our solution, step number 3 implementation is the state transition diagram, which is implemented using the state transition table and the machine function table. Now let us solve the step number 4, that is example. So we are going to take the example as QS, 8342. As we can see, it should be divisible by 4. So when we are in QS state and I get first input as 8, we will transit to Q0 state. When I reach Q0 state, the next digit I am getting is 3. So I transit to Q3 state. When in Q3 state, if I get the next number as 4, I transit to Q2 state. When I am in Q2 state, I get the next input as 2. I transit to Q2 state and the output should be no, it is not divisible by 4. So here through the state transition diagram, we can clearly trace down the transitions that should take place for solving this particular input. Let us take another example, QS, 312. When we are in QS state, the first digit appearing is 3. So I transit to Q3 state. When I am in Q3 state, the next input I am getting is 1. I stay in same state, that is Q3 state. And finally, when I am in Q3 state and I get 2 as the input, I transit to Q0 state and I will give the output as Y, that is yes, the number is definitely divisible by 4. In case you have any queries, you can just simply put down your questions or queries in the comment section and we can solve it in the next session when we meet. See you then.